Welcome back, colleagues. This is Learn Extra Teacher Talk. Our focus today is on physical sciences. We've been in discussion with Dr. Angela Stott from the University of Cape Town, and we've been talking about her research and her experience in the classroom, and we're going on now to deal with the approach that you've developed, that you've called the ladder approach. So please just take us through it. I know that we've got a graphic here, but we can start at the bottom, I'm presuming.
Right, just like with a ladder, you have two parallel things which are always present, although, just like when you climb a ladder, your focus shifts from one to the other as you climb. And these two are engagement with a problem task and direct teaching.
Okay.
So what happens is you start off, now this can be very small scale, just for one lesson. The entire ladder approach can happen within one lesson.
Sure.
Or it can happen within a unit. And that's more what I'm speaking about now, although obviously, you know, it's not restricted to that.
Sure.
Okay, so at the start of the unit, I would introduce this unit by posing an interesting problem, which is too complex for them to solve right then. And it's not just a problem like with numbers that you must plug numbers in. It's something that will interest them because it's got something to do with concepts.
And context as well?
Definitely, yes.
Relevant to the context of the learners.
That's right. And then they'll first just brainstorm that a bit to make it their own and raise questions of what they need to learn in order to be able to solve this problem. So that then the learning becomes theirs because they've raised the questions. It's not just my questions, it's their questions that the teaching is now answering. Then I go to direct teaching. But while I'm teaching directly, I'll continually, where appropriate, refer back to the context, to the problem, so that the teaching isn't just, you know, a pie in the sky and who cares, but it's grounded in something that makes sense to them, that matters to them, hopefully. Then, after teaching a certain amount, then I'll get them to apply that learning to a part of the problem. And I'll do that by means of worksheets. Those are the rungs of the ladder.
So you start with an introduction, and then what you've written over here is scaffolding
worksheets.
Worksheets.
Yeah.
So they're little steps leading
Exactly.
to the solution. It's not just finding the whole solution.
That's right, yeah. And these worksheets, they scaffold the process. That means that they guide the learners where they need guidance, because it's too difficult for them to manage on their own. So these worksheets get the learners to apply what they've just been taught to the particular context of the problem. And so they answer that partly individually, partly, so like with a ladder, partly they've got to, on their own steam, climb the ladder.
And that goes back to making effort. They can't just sit back.
And it's not a slide, it's a ladder. They've got to climb, it's effortful. And then partly also through discussion with peers. Because in our introduction, we were speaking about, you know, the phasing in of OBE, and they said that, you know, group discussion will get them thinking critically. And there is some truth in that. It can be very powerful. It can be just a waste of time as well, which is what many teachers have realized. But I found that if it's directed, if this group discussion, which is them pulling one another up in the picture, if it's guided by these scaffolding worksheets, which is quite specific to what's been taught and to the context of this problem, then that discussion time was very productive. So they're helping one another up, and then you can see the teacher there at the top, also actively pulling the learners up. Because many teachers think when we get the learners discussing, then that's the time that I do my marking or I drink my tea. And that's not so. This is an effortful process. Good learning, deep learning, critical thinking doesn't happen by itself, not at all. It's an everyday struggle. And the teacher needs to be there pulling the learners up, continually challenging them, challenging their, you know, where they speak superficially, and getting them to challenge one another and providing the content knowledge where they're missing that. So sort of like expanding their working memory in terms of what we spoke about before, like acting as an external hard drive. All these things the teachers needs to be there for.
being the sounding board, that the learners
Indeed.
and giving them back those questions, that they're not necessarily giving them the whole answer all the time.
Very much so. Yes.
But probing and getting
Yes.
the learners to start thinking about how they're coming to solutions as well.
Yes.
So there's some metacognition happening there as well,
Yes.
I'm presuming.
Yes, because the learners themselves are probably not in the state where they are able to apply the metacognition themselves. You're trying to lead them there.
Yes.
So you do so by acting like modeling what they should be doing to themselves. And it's really interesting, it's really so rewarding as you start hearing them then start asking themselves and one another the kinds of questions which you keep asking them.
Correct.
Yeah.
Okay. Yeah, that's really good. So can we look at some practical examples of the ladder method?
All right, so let's start off with an example from the
Okay,
FETO.
sorry, let's just,
Yes,
so
first
perhaps
of all,
just deal with the process.
This is a timeline of actually a section, mechanics, which I did in the ladder approach. And what it shows is how I used the various hours that I had of class time. So you can see that first of all, they were just brainstorming the problem. And then after that, the red is where I was directly teaching. So then, with our ladder, we're shifting our focus to the side. And then there's a time when, actually for homework, not shown here, they answered that scaffolding worksheet. And then in the black stripe, now they discussed what they'd answered in class with their peers. And then I taught the next little bit, next red, and so on. We go back and forth.
So it really does show quite a nice interaction with those two components.
That's right.
Feeding off each other. Great. And at the end of that, you're hoping that they're not only get through what's required in the curriculum, but they have success in their summative evaluation.
That's right. Now, even in one lesson, you can undergo that. Obviously, the time will be different and you won't have as many of these back and forths. But you could start with a problem, you teach a bit and then get them to discuss something, teach a bit, discuss something within one lesson.
Okay. Well, let's have a look at that problem that you were going to say.
Yes.
The unbroken egg.
Okay.
So I know that you've got a little video clip.
Yes.
So let's open up the video clip, which I think it shows the problem quite
Yes.
nicely. The egg being thrown up, falling on grass. So what was the problem around that?
When you throw an egg up and it lands on grass, amazingly, it doesn't break.
Okay.
So this is a nice context in that kids are fascinated by that. They wouldn't expect that would happen.
Yes.
So then you pose the problem, why? You've got to explain, why does it not break on grass? And maybe also, well, what kind of grass might it break on? What would make it more likely to not break if you even throw it off from an aeroplane or something? What kind of grass might help, So there's a bit of complexity there. Yeah.
And from what height?
Exactly.
Yeah.
Yes.
So there are a whole lot of possibilities in
Yes.
terms of looking at the problem.
So I used this for grade 11 mechanics.
Yes.
So at the start of the mechanics section, you spend quite a while on mechanics, maybe roughly a month, depends. But so at the beginning of that, I posed this problem, played them that movie. They actually went outside and they tried, and they said, oh, this is really so. And then I got them brainstorming. Okay, well, what's happening here? Why doesn't it, what do we need to learn to be able to explain this?
So this was before you'd even laid any foundation in terms of Newton's laws
That's
or what a force is or anything like that. It was just, here's the problem.
Yes.
And it's quite a challenging problem. It's not a low-level quick answer, is it? And I think that's sometimes one of the problems that we have is we don't raise the bar to ask complex problems.
That's right, yeah.
Okay. So then what was the next step?
Okay, so that was the first rung of the ladder, the introduction and then brainstorming. Then I got teaching about force.
Yes.
And then they had to apply what I'd taught about force to the egg. So I had a worksheet. So you can open the worksheet.
Okay.
And in this worksheet, it asks about, they must draw a force diagram of the egg at various stages, and the egg on the concrete and the egg on the grass. Later then I taught them about momentum and the rate of change of momentum.
Okay.
And then so you'll see here there are a number of scaffolding worksheets. I think I call them interim reports. Information about force. Draw a force diagram for the egg. and before the impact after.
Okay.
So now they're applying what I taught them about force just to a part of the problem of the egg.
Okay. And you've changed here as well the surface as a variable. So it wasn't only on grass, but it could have been on a different type of surface,
Yes.
like concrete.
Yeah, because actually what they had to do is explain why does it not break on grass, but it does on concrete.
Okay.
Yes. So then I'd teach the next bit, and then there'd be the next scaffolding worksheet, and the next bit, and the next scaffold, and so on.
Okay.
Yes. And then by the time I'd got through the whole curriculum, they had built up the explanation of why this egg breaks on concrete but not on grass from many different angles, explaining in terms of power, rate of conversion of energy,
Yes.
and
Rate of
impulse.
Impulse, yeah.
Yes. And then also creating numbers for themselves of possible, that might be reasonable, and putting them in equations and drawing graphs and, manipulating the equations of impulse.
Impulse, yeah.
Impulse, yes.
And getting the concept of the rate of change of momentum.
Exactly, yeah. So then they had to now produce something that I could get a mark out of.
Yes.
And there as well, I realized that you can't just leave it up to them. I've realized that often teachers think, if I'm going to get them thinking critically, I need to leave it up to them. And then they just, like the research projects they have to do, they just give them a topic to research and bye, and off you go, and you just find everything else yourself. And the thing is that they do not apply critical thinking there because it's difficult. They can't. You have to guide them.
Yeah.
So even in the final summative assessment thing, I also gave them guidance. So I gave it in the form of a PowerPoint, although I printed it out if they didn't have access to a computer.
Okay.
And so each slide tells them what they have to do for that slide. So it's quite clearly guided, but not in such a way that they don't need to think.
Let's just see if we can get state the problem, draw the force diagram, and then during the impact with grass, gives some particular questions, and it's tying the loose ends together.
And it's linked to those scaffolding worksheets done earlier, so
Okay.
that that it's not just leaving them up to, whoa, it's a big thing they have to do on their own.
And they did this on their own in a controlled environment.
They did it individually, yes. Although they discussed with one another at those points in that graph that I showed you.
Yes.
But they had to actually do it in writing alone. Now I know that there is the problem that they can copy from one another. So I tried various things. One thing that I tried was that in a controlled environment, I said, okay, so you can bring all your scaffolding work, your previous reports, and you can sit here and you've got to actually write it under my supervision. But actually what I found, and that did work quite well, except that they wanted to do extra. They wanted to do so much more, which is fantastic,
Yes.
But so that it took longer than the required time, simply because they wanted to actually do other contexts, which I haven't explained here, for bonus. And so I realized that they weren't copying from one another, or I could see if they were copying from one another. So I did actually even allow them to do it at home. But you've got to know your learners.
Yes. Obviously, with those initial reports, that had feedback as well.
Oh,
So-
definitely. That's a very important part. That's part of the picture of the teacher lifting. So it's not only during the group discussion the teacher needs to be lifting, but also I had to take those worksheets in and check that they were done, and also give comments back to them where they weren't understanding. Sometimes I saw a general problem amongst the learners, and then I'd to everyone.
Yes.
And sometimes just a particular learner, then I'd maybe write a comment.
Okay. Let's have a look at one other example now. I know that you mentioned that this isn't perhaps for the learners in grade 10 to 12, but I think it does illustrate a point in terms of the ladder approach as well.
Yes. So this one I actually did for grade 8, and it's called Race in Space. And what they had to do, their big interesting problem, is that they have to choose a place where the, I think, 2030 Olympics would be held, but it has to be somewhere in space, not on Earth. And now, you see, often in these kind of questions, the teacher will just say that and then leave it to the kids. And as I've said before, not much critical thinking happens. So again, it's very clearly structured. And I don't just want them to be creative and say, okay, let's all just go to Saturn. But they have to say, why do they want to go there? Why is it better than elsewhere? What are the things that you have to take into consideration and evaluate the various places against that? So this here, they did it actually in groups. So a group produced one of these PowerPoints. This is the PowerPoint that, the template that they use. So we can just progress on the slides, yeah? So here they've got to actually, well, that's just the instruction. They've got to decide where to go to. This one here is quite interesting. It's actually linked to everything else if you click the stars, but we won't do that now. And they've got to change the relative orbiting times so that it's more like it really is, and the instructions of how to do that. But that's more just for fun. Let's progress.
Okay. Do you want to go to...
Just to the next one. All right. So what they had to do, each child in the group had to take one place and research about it. You know, what is it like there, and then think what are good aspects about it that might make it a favorable place to have the 2030 Olympics, and what are bad aspects. And so each child had to present that. And then after all of these slides which are just templates for them to present that, then we get to looking at aspects about the various places that might be relevant. So for example, there's stuff about the distance of each from Earth, which is of course relevant because we don't want to have to take too long. Yeah. So here, so now they've got the individual things. Now they need to synthesize that and decide, well, which is the best place and why. So one of the factors is distance from Earth. So there's a link to this from here to an Excel document where they put in the information and it draws a graph for them. Okay. And so they have to search for the information. This is about the sizes. Yeah, I don't know whether that's awfully relevant, but anyway. Well, so they have to find the information about the sizes, and then they put it in the Excel document. Gravity obviously is relevant. Important. Yes. And then later on, one of the slides says, there we go, that they've got to generate a list of criteria. Remember, with critical thinking, one of the criteria of critical thinking, yes, is...
And you must be able to evaluate.
Criteria. Exactly. And that's the part that's difficult. And that's the part that's not done when the kids are just left up to themselves. So now they've got to come up with criteria and then say why their choice fits those criteria best of all the options. Okay. And that's the part which really is difficult. Yes. Yeah. But being guided like that, they manage it.
Yeah. And all the time while we're doing this is we're not just doing this for fun, but we're doing it because we're wanting to promote understanding of the topic.
That's
and we're wanting to make sure that learners are actually learning good physics.
That's right. And you see, the thing is that context affects motivation. If you can get the kids motivated, you've won half the battle. If you're trying to teach kids and they're not on board, it's really, really tough. Yeah. So that's why I think that the context is so important, because when they're motivated, their short-term memory, their working memory expands, they spend more time on task, they learn better. Yes. And critical thinking is difficult, so you need to have a lot of motivation to do it. You're not just going to do it. Well, most kids are too lazy to just do it
on their own.
So that's why I think the context is so important in the ladder approach.
Okay, so now the effect of this ladder approach. I mean, that's obviously the critical question now. Yes. Have you seen it being introduced, and what are some of the effects in terms of both the teachers and the learners? Yeah.
Well, I've only done it in my own classes. I haven't actually had access to teachers to show them how to use this method before. This is the first time I'm getting that opportunity. But with my own learners, well, that's how I teach all the time now, because I've been so convinced that it's really so beneficial. Because I'm sure all teachers know that kids tend to be lazy. And you've got to, try and keep them in the class until the bell rings. And you've got to try and force them to do their homework. What I found here, I had to force them out the class at break time because they were so involved. I'd walk
because
around,
they've got that curiosity, they've got that inquiring mind. And
I'd walk around the playground at break time, and I'd find little huddles of groups discussing Newton's first and second laws. I mean, where do you find that? Yeah. And I must just stress, though, that might sound like it's just all rosy, and definitely it's worth it, but it is obviously difficult to get the kids to think because they're lazy. It requires a lot of effort. It requires a lot of belief in yourself that it's important to develop critical thinking. And you've got to be really pushing it every day. But when you do that, what I found is that the reward is so huge, it's worth that effort.
Yeah. And these children that you were teaching, they weren't in a privileged environment.
No, not at all. Not at all.
They're in a rural school.
Yes,
yeah?
That's right.
So we recognize that this can work anywhere. It's not just that it could work, obviously, in the hands of a skilled practitioner.
That's the thing. Yes.
It needs that thinking and that careful understanding. And I'm sure that if people have questions, you'd love to get some response. So, colleagues, I hope that you've enjoyed our time with Angela, and please post onto Facebook. If you have any questions about this, we'll make sure that we'll put you in touch with Angela, and you'd like to know a little bit more, we'll get you the information. So thank you for joining us today, and thanks for being with us, Angela. I hope you've enjoyed this opportunity. Thank you very much. We'll see you again next time. From me, John, goodbye.